Good morning, everyone and madam. My name is FONG and my matrix number is 01D8023F1001.
Hello and good day to everyone. My name is Joshua Wijardrun. My matrix number is 01D8023F1006.
Good day to all. My name is Komingjan and my matrix number is 01D8023F1013.
Hello, Assalamualaikum everyone. My name is HILAMN bin MULTAZAM. I'm student Politeknik Ungku Omar. My register number is 01D8023F1003. Today I will be present about vector and scale in real life application.
Today, I will explaining the introduction and conclusion vector and scalar. So, let's move on to an introduction to vector and scalar. Understanding vector and scalar is not impossible to everyone. I think that everyone can understanding the meaning of that. So, what is the difference of vector and scalar? Vector and scalar. Vector refer to quantities with direction, whereas scalar only have magnitude. Scalar include magnitude only. Vectors are multi-dimensional and directed. Vectors have magnitude and direction and are represented by arrow. Scalar are one-dimensional quantities. Scalar have only magnitude and no direction and are represented by a number of quantity. Vector quantities are addition, subtraction, and multiplication. Scalar quantities are only addition and multiplication. Vector combined with scalar. Vector have direction, scalar doesn't have. Scalar and vector in real life. Vector are used to represent velocity and displacement. Scalar are used to represent temperature and mass. Application of scalar. Scalar are used in mathematics, economics, and statistics. Use of vector. Vector used in physics, engineering, and graphics.
Today I will talk about real-life application of vector and scalar in engineering. Basic mathematical ideas like vector and scalar are widely used in many different engineering specialties. The following are some practical use for scalar and vectors in engineering. Vectors that used in mechanical engineering is force vectors. Force vectors are used by engineers to describe the force operating on mechanical parts. Understanding the influence of force on the design of machine and structures is made easier with the use of vector analysis. And second, vector used in electrical engineering is electric field. Electric fields, which are essential to electrical engineering, are represented by vectors to ensure that electric fields are distributed and controlled properly. Engineers use vectors in their circuit analysis and design process. And now, let's talk about scalar use in engineering. Scalar use in engineering is energy in electrical engineering. In electrical engineering, electrical power is a scalar quantity. Engineers measure and optimize how much power is used by electronic system and device. The last scalar use in engineering is temperature in thermodynamics. Temperature and other scalar quantity are important in thermodynamics. Temperature measurements are used by engineers in the design and optimization of systems, including refrigeration and heat exchanger. When choosing materials that can endure high operating temperature, engineers design an engine must take scalar temperature into account.
Thank you, KHOR. Now moving on to my presentation today. What I'm going to present today is the mathematical solution with drawings. Let's give a scenario. A car is being held by a 3-wire cable with point P, Q, and R. Using the formula we have learned, calculate the area of triangle P, Q, and R. Actually, pardon, it was vector P, Q, and R. So, how do we find it? Well, as given at the picture here below, P is equals to 5i plus 7j plus 1k, whereas Q equals to 6i minus 2k, and lastly, R equals to 7j plus 3k. Moving on to the next slide. Over here is a mathematical solution where the drawing was in front. So as we have seen here, we should note out first the formula of area of triangle vector PQR, which is 1 over 2 times the modulus of vector PQ times vector QR. So how do we find PQ? We can find PQ and QR by making it the vectors, where PQ equals to vector PO plus vector OQ. We already have vector OQ. We also have vector OP. But how do we find vector PO? Well, to find vector PO, we need to reverse the position of OP into PO by making it negative. So after making it negative, the results we have for vector PQ is I minus 7j minus 3k. Well, for vector Q is also the same situation as for vector PQ. We already have vector OR. We also have vector OQ, but we don't have vector QO. So same situation, we'll just minus it. So after we made a vector OQ negative, the last result we get it is negative 6i plus 7j plus 5k. After getting these two vectors, we should multiply it by using the formula of modulus ijk, where below here, where below the second row is implying the vector PQ, where the third row is implying the vector QR. So after the multiplication done, the final result we got is negative 14i plus 13j minus 36k. At last, we got the answer for the area for the multiplication. We also have the answer. So later on, we got the answer of the multiplication. We'll substitute back using the formula as stated on top, which is 1 over 2 times modulus of vector PQ times vector QR. Moving on, we'll be taking 1 over 2 times the modulus of vector PQ times vector QR, which is 1 over 2 times the square root of 14 square, negative 14 square, plus 13 square, plus negative 36 square. And last, our final answer we get of the area of triangle vector PQR is 20.38 units square. That's all I have to present today. Now I'll be giving up the slide to the next person. Thank you.
Okay, this is mathematics solution with drawings part 2. Okay, this question is person A and person B is pulling a boat. Using the formula you have learned, calculate the angle between A and B. Okay, you see this picture. This picture is angle, and you can see it is very simple question. You know. Okay, you see A equals 6i at 2j at 6k. B equal 9i minus k. Okay, this is second picture is a solution mathematics with drawing parts 2. Okay, the second picture is you see and is calculate. We use tambah tolak darab bahagi, you know. Okay, the final answer is 52.55 angles. Okay.
It is the last part of conclusion. Vector quantities have both magnitude and direction. They can be added and subtracted graphically and by using components. Vector can be broken down into components. Vector can be multiplied by scalar. Besides that, the meaning of scalar is the scalar quantity have only magnitude and can be manipulated by the rules of arithmetic. But the vector component are the projection of a vector onto the coordinate axis. Scalar multiplication of a vector change the magnitude of the vector but not its direction.
Okay, the feature reference, you can click these three links. I give three links for your click for future reference. Okay, see you next time. Bye bye.
Thank you.